Welcome, guys. So we keep solving physics GRE and 75. A uniform thin film of soapy water with index reflection, 1.33 is viewed in the air via reflecting light, and appears dark for a long wavelength, and the first appear bridge is 530 nanometers, while the next shorter appeared bright. Okay, so 75. So there's a soapy water, index is 1.33. So there's a light. Okay, and I should plot here, right? So the this because this is equal to 1, so there would be somewhere there will be a 180 phase. So the light and the constructing interference has the condition that if this is t, then it should be 2t equals to m plus half lambda. So this half comes from the phase 180 from from this wave, because this is from small equals to 1 to 1.33, so there will be a phase difference here. Okay, so we can solve this. Okay, this is so basically this lambda is not the wavelength in the air, but it's the wavelength into the in the soap. So this lambda should be written as lambda divided by n. So okay, so the first one is m equals 0, so we have 2t equals to lambda divided by 2n. This is the first one, first equation. The second equation basically is 2 lambda equals to half for some unknown lambda divided by n. So basically you can see the 3 lambda tilde should be equal to lambda. So the answer is just 540 divided by 3. So the answer is 180. Just use this equation. Okay. And the 76, basically you see, basically you can guess this is a Snell's law, right? All you need is Snell's law. So optical fiber means then the total reflection. So basically, okay, so let me draw a graph. So this is theta, and suppose this is phi, and the index is n. This is 1. So basically we have sin theta equals to n sin phi. And then from here we need it to have the total reflection. So basically in here we have this is sine pi over 2 minus phi times n. It needs to be 1. So we have the two equation. And all the goal is we need to eliminate the phi and get the theta. So we have n cosine phi equals to 1, and the n sin theta basically is n sin phi is sin theta. Okay, so we can solve it. What we get is, let me see how to solve it. We can square it. So we basically square both, and cosine square plus sine square is 1. So we have sin theta equals to sine inverse square root of n squared minus 1. Okay, so this is the equation we have. So we can get the answer is A or B. It's A or B. Unfortunately, we need to find A or B, which one is correct. So remember that when theta increase, phi will increase, but phi increase, cosine phi will decrease. So this condition cannot be maintained. So theta should be smaller than this angle. So the answer is B. Okay, so 77. Basically, it's asking about Lumen square. Okay, oh no, it asking about average time. Okay, but this is basically related to the Lumen square velocity. So Lumen square velocity, you need to remember. I already said that this is important. You need to remember. Okay, and the collision time basically is L divided by V. Okay, so the answer is just the square root of m. That's it. So 78, you have E1, E2, and the temperature probability. Okay, so basically this is you know that the probability is proportional exponential E divided by kBt. So for the probability state 2, you have this one, E2 divided by kBt divided by exponential minus E1 kBt plus exponential minus E2 kBt. So this is the answer. Okay, so we can which one? Okay, so we already find the answer. The answer is B. Once you know this, then you can solve it very quickly. Okay, 78 and ask you about this is the Obed van der Waals equation, and ask you about if gas understand isothermal. So isothermal is important that you know that isothermal means the temperature is fixed. Okay, so let me tell you something. Isothermal means T is fixed. Isobaric, it should be A. Sorry, isobaric means that P is fixed. Okay, so these two terminology you need to remember. And ask about work. Okay, so means that a work is PDV, right? So P is equals to RT minus V divided by V minus B minus A V squared dV. From V1 to V2, so this is the answer. So this is RT log V minus B plus A over V, and V2 V1. Okay, so the answer is what? Answer is should be D. Just plug it into, you get this one. Okay, so it's easy. So 80, 1 kilometer block attached to a spring vibrates with a frequency of 1 Hz on frictionless horizontal table. Two springs identical to original spring are attached to a parallel to A, and then which of following gives the frequency. Okay. So maybe we'll draw a graph. Is easy. So the first one is that there's one mass and attached to some vibration K. And the second is you have two similar originally but parallel to 8. Okay, and ask about the frequency of the 8. This frequency is 1. Okay. So formula you need to remember is this. So this tells you that F is 1 over 2 pi K over M. Okay, so this tells you that 1 is proportional to 1 is 1 over 2 pi K over M. So this is the first equation. And when you parallel the spring, what you get is what you get is the effective constant is 2K. You need to remember in parallel, you need to add them together, and then this is 8. So what we want to compute is this 2K divided by AM. So basically this is half 2 pi K over M. So it's a half times 1. So the answer is 0.5 Hertz. So the answer is C. Okay, and 81, a uniform disk with mass and radius r rolls without slipping along a horizontal surface and ramp. I show the disk has velocity v and what's the maximum height. Okay, so basically, if somebody asks you a maximum height, all you need to think is the energy conservation. Okay, so and you need mgh equals to the total kinetic energy, the total energy. So total energy from here contains the kinetic, the translation plus rotation. And the important things in the physics GRE is you need to remember this formula. Also, this is a unit disk, so I is equals to a half mr squared. This also you need to also remember this. And the V is also to R times omega. Okay, so nice, we can solve it. Okay, so this one is a half mv squared plus a half, so I is this one, omega squared. And then remember that the R omega squared is V squared, so this is a half plus 1/4, so it's 3/4 mv squared equals to mgh. So we can solve h is 3v squared divided by 4g. Okay, so the answer is B. The answer is B. Okay, 82. This problem is reason here is very popular. You just ask about Lagrangian. So Lagrangian is the kinetic term minus potential term, and the potential term must be positive. Okay, so the answer, the only possible answer is A, B, and D, because you need some positive minus or negative, some positive minus negative. Okay, so the rest is we need to figure out what is the potential term. So that there is a mass attached to a mass that spring fixed, and mass is confined to move a horizontal plane. Okay, so maybe I should put horizontal plane. Its position is given by the pole quantity and R is theta. So basically, you have R theta, and it relax from a spin. Spring is in S, and the force constant K. Okay, so that means S is our original starting point, and after that you somehow go to R. So it's just a half kx squared, which S is the strength length. So basically it's R minus S squared. So this is the potential term. So the answer is D. The answer is D. Okay, 83. I basically asked about common Hamiltonian dynamics. Somebody give some. You don't need to see the graph. You already know the Hamiltonian. And then you ask about on the basic equation, the generalized coordinate momentum is constant in time. Okay, so let me remind you guys that so Hamiltonian dynamics based on P and Q, and the equation motion is partial P, partial Q, partial H, partial P, and partial H, partial Q. And then this is Q dot, this is minus P dot. Okay, so which one is constant? So one is we need to compute the partial base theta, and the partial H partial theta, and the partial H partial P phi, and the partial H partial phi. Okay, so which one is constant? Nice, we don't know, right? So we need to compute. Okay, but somebody but he asked about the general mode, which is constant in time. So remember, it's constant in time. Okay. So the answer is obvious because partial F partial phi, which is 0, and then this is by definition this is P phi star, minus P phi star, minus P phi star, minus sign. Right, so this tells you that the P phi, the derivative to the P phi to respect to time to P phi star is 0 from here. So it just tells you that P phi is constant. So you see this equation, because there's no phi dependence, so P phi is a constant. So the answer is E. The answer is E. Okay, 84 said that a rod of length L and the mass is M, and then there is some strange linear mass density, and ask about following give you the x coordinate. Basically, this is not a physics, right? This is basically calculus. The mass. So the center of mass is you have a total mass and divided by the numerator is x times density dx, right? This is the formula in the calculus. Okay, so we can solve it. By the way, you can see the density is linear in x, so that means the center of mass should close to the right of the should larger than L divided by 2, because when x is larger, then density is larger. So all the mass, so the right the half right should contain more mass. Okay. So how about we do the integral? Right. So nothing special. We just plug in x and do the integration. Right. So we just collect the cancel m, and 1/2 over L. Right. So we cancel it, and let me see. Oh, there's a L squared. Sorry, I missed one L squared. So here we just do to the L squared times this x squared dx. So it's 3x cubed divided by 3 and L0. So basically 2 over L squared, 3 over L 3, and this is L cubed. So L, we have 2L over 2L divided by 3. 2L divided by 3. So the answer is E. So just use this formula, right, and calculate the center of mass. This formula basically comes from calculus, so nothing is special. Okay, sorry about that. So if you want to calculate y, then you can just change this x to y. If you want to calculate z, just calculate x into z. So basically this is, then change this. Okay, so I think it's enough for this video. So we stop at 84, and hope we can solve it without so much consideration. And be sure to subscribe to my channel. Thanks.